Okay. Hello, um, and welcome to another video on Apply Electricity. My name is Dr. Osman Hassan. Um, Please share this video with other students that are in different departments, right? So, for example, electrical and electronic department, mechanical. I think almost all the department, except some few departments that are in the university that are not taking uh, apply electricity, but most of the department they have to take apply electricity. So if you have a friend, it's most likely that your friend too is also doing apply electricity. So share this video with your friends, and this will go a long way to help them boost their apply electricity marks, right? Especially in the final exams. So starting with the first question, right? So I'm going to be solving first semester examination 2022-2023 academic year. That was last 2 years. Then once I'm finished with this, I'll be solving the examination for last year, meaning that will be 2023-2024 academic year. So let's start with the first question, which is given here. You can see that the first question that is given, we have question 1, right? We have question 1 here. Now, DC current is when the A, direction changes with time, magnitude changes with time, magnitude remains constant with time, magnitude and direction changes with time. So here the answer is going to be B, right? We have here to be B. The answer here is going to be B. Okay, why? Because when you have a DC, right, meaning direct current, you have a direct current, it looks like this. So if you can just remember to sketch a graph of this, right? We have question 1 here. So when you have DC, you just tend to have only a constant magnitude, meaning a constant value. So let's say you're having a current of 10 amps, right? So you just have 10 amps. So irrespective of the time here, we are going to always get time. So the magnitude remains constant with time. An alternating current, question 2, an alternating current of frequency 50 Hz and maximum value 200 amps is given as A. We have I equals 200 sine 628 t. Then we have B, I is equals to 100 root square of 2, then sine 157 t. And then D, we have I equals to 200 sine 314 t. Now, so if we are given this, when you are having a sine wave, right, or a sine wave is usually going to be equals to what? Meaning you have the maximum. For this one, we are dealing what? Alternating current, right? So meaning I'm dealing with current, so we have the maximum current will be equals to sine omega t, right? So this is going to be our sine wave. Now from this, we can see that here the maximum value for the current, which is given here in the equation as 200. So I mean I can come here and replace here to be 200. So I have 200 sine already. Now I left what? Omega t here, right? So we know that omega is what? The angular velocity. And angular velocity, we can calculate it in terms of frequency because we are given the frequency here, which is 50 Hz. So with this, we can write angular velocity is going to be equals to 50 times, okay, let me write the formula first. We are going to get 2 pi f, that is the formula, and then that means we have 2 pi, the frequency is 50, meaning times 50, and that is going to give us 100 pi. So 100 pi will give us what? Meaning 100 times pi, and that gives us 159. So you round this off, you get 1.6, meaning 314.16. So when we come and then look for this, so meaning my alternating current is going to be 200 sine 314.6t. So if you come and look at the answer, you can see that our answer here is going to be D, right? So we have D as the answer for question 2. Now we move on to question 3. Okay, question 3 here. The root mean square value of a sinusoidal AC current is equal to its value at an angle of that's in degrees. So here, what this is trying to say that if you are given the root mean square value, so if we know that root mean square value, let's say for what here we are talking about root mean square of a sinusoidal AC alternating current. So let's say we are having alternating current, right? Then in that case, my root mean square value for current, right? The current will be what? Let's say R. Okay, let me write this very well. Okay, let me write RMS, right? Will be equals to 0.707 IM, right? For current, right? Now, if you look at the relation between this, right, and then this one, you can see here we have 0.707, right? Now that is going to be the same as what? 1 over what? Root 2, right, times the maximum current. So we have this as, and then here you realize that 1 over root 2 is the same as or equals what? Sine 45. So we can have here Im here sine 45. So you can see because of that the angle here, right, if we're to express the relation between the root mean square value and then the maximum current, right, right, so you can see the angle we are adding 45. So mean the angle here, which is what they are interested in, is 45. So we come and take our 45, which is A. So we have question 3 to be equals to A. Now let's move to the next question, which is question 4, right? Question 4. The electric iron is rated as 100 volts, 300 watts AC. The 100 volts refers to the A, the peak value, B, the average value, C, the root mean square value, and then D, the peak to peak value. Okay, so here the answer here is going to what? C, the root mean square value. Remember, the root mean square value is a value that is always indicated on the appliance, right? Even when it comes to the values that we tend to use during calculations, mean the voltage values that we use during calculations, those values are mostly expressed in root mean square value. So from if you can remember from chapter 2 to chapter 4, the voltages that we are given, right? So you are given a voltage source of, let's say, 100 volts, 200 volts, or 24. Those were the root mean square values, right? So if you are given an appliance like an electric iron, so the 100 volts there is a root mean square value. So we have here to be C, right? This is C. Now we go to question 5. The following statements about pure resistive circuits are all false except, so meaning all these statements, all of them are false except one, meaning one of these statements is supposed to be correct. So we have a power factor is unity, right? So here, if you check where you realize that this one is correct. Why? Because we know that power factor is equals to what? The active power over what? The apparent power. So if you're having a purely resistive circuit, right, that means that we don't have any reactive power. So it means that, let's say, the active power, which is going to be equals to what here, which is going to be current and voltage sine what, or it's supposed to be cos, right? Cos, let's say cos the phase angle. But since it's only purely resistive, that means here we don't have any phase angle. Remember, the phase, the voltage and then the current, they are in phase, so the phase angle is 0, right? So if you were to write this over the apparent, which is this formula, so this phase here, the phase angle is 0, so this become 1. So you have now current times voltage over current times voltage. So you get this to be equals to 1. So you can see that the first part of this question is actually correct. The first part of this. So this one is correct. But let's continue and look at the rest. So B here, the power factor is 0. No, the power factor is not 0 if you are having a purely resistive circuit. Then the C, power consumed is 0, meaning just the power is always 0, which is wrong. Then D, heat produced is 0, that is also wrong. So you can see that the right answer here is what? A. Now let's go to question 6. Question 6. Two sinusoidal currents are given as I equals to 100 sine omega t plus pi over 3, and then I2 equals to 150 sine into brackets omega t minus pi over 4. What is the phase difference between them? Here, this question, you can actually approach it in 2 ways, right? One way is to, you can sketch the sine waves for each of these sine waves that are given, right? I mean, you can have a sketch of each of them. Then once we've done that, then you can now look at the phase angle between them, right? The angle difference between the two sine waves. And one way is, which is the easiest way, is by sketching the phasor diagram, right? Or the phasor diagram of each of these sine waves, right? So to do this, I'm going to be using the second approach, which is just to sketch the phasor diagram of each of these sine waves. And then once we've done that, we look at the difference, right? Meaning the angle difference between the two, and then that will give us the answer. So in using the second approach, so if I'm giving this, right, we have I1, which is equals to this. Now I'm going to now sketch this in for I1, right? So if I'm sketching for current, the sine I1 here, in terms of the phasor diagram, I'll have And then you can see here, for example, you can see here we have pi over 3. So this one is just indicating to me the phase angle for what? I1. So the phase angle. So we have this formula, 100 sine omega t plus pi over 3. So this one is the phase angle of what? For I1. And then we can convert this to what? To degrees, right? So you can see here is pi over 3. When you do this to convert this is in radians, so you change this to degree. You can get the answer by, so we have this. So you can get pi over 3 in degrees by saying that, let's say pi is equals to 180 degrees. Then if I have pi over 3 here, s, right? So you cross multiply, you get this one to be equals to half pi over 3 times 180, right? Then you divide by pi again. So this pi will cancel, so we get here to be 60 degrees. So you can see that here the phase angle for I1 is 60 degrees. Now let's get the phase angle for I2. Again, you can see that this one too, we are having rather, here is rather minus, right? So we have here minus 4 pi. Sorry, minus pi over 4. So here again, phase angle in radians, here is minus pi over 4. So when you change to this in degrees, right, it's going to be the same as one. I'm not going to go all the way for it, but you get what? Minus 45. So you use the same method I just did. You get minus 45. So now that we've gotten this, the next step is to sketch the phasor diagram for each wave. Alright, so if I have my I1 here, in sketching the phasor diagram, I know the phase angle is 60. I mean, that is in terms of the origin. So I'm going to have here, say I have my origin, right? Then I have 60 degrees. So here is positive value. So meaning I have here, let's say I have my I here. I have this angle to be 60 degrees. And then that is for, let's say I1, right? Now for my I2, you can see that the phase angle is minus 45. So minus 45 meaning it's going down, right? So here you put, so I have here 45. So meaning this is, let's say my I, okay, let me use this one, small. A small letter here, okay? Small letter. And then here, okay. So here is now 45 degrees. So you can see now, if you go back to the question, we have what is the phase difference between them, meaning between I1 and I2. You can see now that the phase difference is just going to be this one, right? This is going to be the phase difference. And this phase difference is going to be equals what? 60. From here to 60, another 45, you get what? Yes, so you get 105 degrees. So the answer for this, for question 6 is what? D. So we get here to be D. Okay. Now, let's go to question 7, right? Question 7. Average power in a pure resistive circuit is equals to A0, B unity. Okay, average power is equals to A0, No, the average power is not 0 because we are having power, as we know, is what you are multiplying current by voltage, right? So you can get 0 in that case. And then we have that is for B. We have C, product of root means square or effective value of current and voltage, right? So you can see this one is correct, right? When it comes to power, right? Even if it's average power, we are going to be using current times voltage. And remember, these are the what? The root mean square values, right? RMS values. Right. Then let's go to question 8. When two waves are in phase, they have peak values at an interval of A, 90 degrees, B, 120 degrees, C, 180 degrees, and then D, none of the above. Okay, so here, question 8. When we say two waves are in phase, right? That means that they have this phase angle is 0, right? If you can remember under chapter 10, I talk about the fact that when you have a purely resistive circuit, what you tend to have is that you tend to have a situation whereby the voltage and the current, they are in phase, right? So I mean, if I have my voltage, let's say my voltage just for only one circle is this way, the current is also this way, right? You can say with with this kind of waves that we have. So let's say the first one is V, right? And the second one is I. You can see that the phase angle is what? 0. So they have peak value. So meaning here, when it comes to finding the phase angle, you can either look at it in terms of the origin or even in terms of what the peak value. So when they are in phase, you see that their peak values are all going to be aligned. There's not going to be any difference between them. So because of that here, the question here is what? D, right? Because when two waves are in phase, the phase angle is 0. So you can see that A, we have 90 degrees, B, 120 degrees, C, 180 degrees, and then D, none of them. So it's none of them. The answer is 0 and it's not there. Now let's go to question 9. Moving to question 9. Question 9. Okay. Question 9. An alternating voltage is represented by V, which is equals to 60 sine 80 pi plus 0.8 volts, right? This is the alternating voltage. Find, meaning question 9, find the amplitude. Here, the amplitude is the same as what? The maximum value, right? Meaning the maximum voltage for this case. So if you were to compare this with what? An alternating voltage, which is going to be equals to Vm sine omega t plus or minus phase angle. Remember, we refer to this as what? The general expression. This is called the general expression. So if you are comparing this with the general expression, you realize that the maximum voltage, which is the same as the peak voltage here, is going to be equal to what? 60. So here the amplitude here is going to be 60 volts. So I have amplitude to be equal to 60 volts. Now we go to question 10. Right? Question 10. Determine the root mean square value. Root mean square value, meaning here we are talking about voltage, meaning the root mean square value in terms of voltage, we know it's going to be equals to 0.707 times the maximum voltage, right? So the maximum voltage here is equals to 60. So I'm just going to multiply 60 by 0.707, and that gives me 42.42 volts. So here we come and look at, we search for the answer. See, we get the answer here to be what? B. So the answer here is going to be B. Okay, you get this into B equals to B. That's for question 10. Now moving to question 11, right? Question 11. Determine the phase angle in degrees. So the phase angle here, you can see phase angle here is what? 0.8. Remember, this is expressed in radians, right? So you are just to convert this to now degrees. Convert this to degrees. And in doing the conversion, we already did one question similar to this, right? So it's the same technique, the same method that you have to use. You can write pi is equals to 180 degrees. So if I'm having 0.8, then how much degrees am I going to get? So again, you are going to get here to be 0.8, you cross multiply, right? Times 180 degrees all over pi. So this, when you take 0.8 times 180 divided by pi, so you see that here we get what? 45. From this I'm going to get 45.83 degrees, which is, here we have 45.8. so here the answer is C. Now let's look at question 12. The root mean square value is the same as the mean value in the case of what? A square. Here it's actually true, right? When you are having the first part here is a square, then when you have what? A sine wave. So when you come to a sine wave, we already have an idea. You can see that the formulas that we wrote, right? For the formulas that we wrote for average value and root mean square values, you can see that if you are having a sine wave here, right? This is what it is. If you have a sine wave, we know that the root mean square value, right, to be equal 0.707. And when you come to the average value, so let's say average voltage, we get 637, right? Okay, let me just come here, 2 divided by pi, so that will be right. Okay, it's 0.637, right? Times the maximum value. So you can see these two here are different, right? So RMS and then average value here, they are not the same for a sine wave. Now what we don't know is what, when it comes to what, the square wave and then the rectangular wave and then the triangular wave. But just if with our own intuition, if you are having a square, right? So if you're having a square wave, meaning you have this, let's say you have pi here, then I have 2 pi, so I have my square wave of this. This is our square wave. So if you have this square wave, when it comes to finding the average value, let's say average voltage, we calculate the average voltage by taking what? Area under the curve, right? So that means that you have an area here, and you take it for what? For half a circle, right? So you take this for half a circle. So in that case, let's say I have here to my VM, right? For this, you can see that if I take the area, and here is pi, so here will just be what? Pi VM over what? Over, again, area under the curve over what? The distance from 0, meaning the distance from 0 to half of the circle, which is also here pi. So I get here to what? VM, right? So if we were to calculate the root mean square value for a square wave, you realize that we are going to get the same answer as VM, right? As VM. So you get VM. So the question here, question 12, the answer here is A. Okay, A. When you have a square wave, the root mean square value and then the sin tends to be 0. Tends to be 0. And then here again, here probably let me elaborate on this. Why here is actually equals to VM. As the name implies, we mean you have root mean square, meaning I have root mean, so you have a root, right? Mean meaning you have the average value. Let's say I'm talking about the average value here. Average value, which is AVG here. Right, square. And then you can see the average value, which is the same as the mean value here, is what? VM. So I'm just having VM over this. So you see that this becomes what? VM. So the answer here is A. Now let's go to question 33. Question 13. Question 13. With question 13, the voltage of a domestic supply is 240 volts. What does this figure represent? So this figure here represents A, average value, B, mean value, C, root mean square value, and then D, peak value. It represents the root mean square value, right? So the voltage that we get from ECG, right? Let's say we get 240 from ECG. So that voltage is what? The root mean square value, right? So it's C. Now question 14. If the root mean square value of a sine wave is 100 amps, what is its peak value? Here we are given the root mean square value to be, okay, here is voltage. So let me make here supposed to be current. Sorry. Here is current. We are dealing with current. So let me use I. It's what? 100 amps. Now, we are asked to find the peak value. Peak value here means the what? The maximum current, right? The peak value here we are dealing with current, so that will be the maximum current, or you can call it the peak current. So we can write the same formula. The root mean square value here will be equal to 0.707 times the maximum current or the peak current. So now we just go ahead, then you make the maximum current the subject. That will be equals to 1. The root mean square current, which is 100. So I'll just take 100 divided by 0.707. So that will give us the answer. So here we have 100 divided by 0.707. That will give me 141.44 amps. So when you come here, you can see we have 70.7 ounce. B is 141.4. So that is our answer. So the answer here is B. Now let's go to question 15, right? If two sinusoids of the same frequency but of different magnitudes and phase angles are subtracted, the resultant is A sinusoid of the same frequency, B, not a sinusoid, C, a sinusoid of double the frequency, D, a sinusoid of half the original frequency. So this question here is going to be A, right? The answer here will be A. Why? Because if you are having two sinusoids, right? Meaning you are having two sine waves, right? Like the example that we saw earlier, right? If you have these two sine waves, so your resultant, meaning after you've done subtraction, you subtracted one from the other, and they have the same frequency. So the frequency will always be the same, right? The frequency will still remain the same. So the phase and then the magnitude is what's going to be different, right? So when you take two sine waves, then you subtract them, you still get a sine wave. So you can see here the answer is A. So you get a sinusoid of the same frequency, right? It's going here the same, but the frequency here is not going to be double. So you get here to be what? A. So question 15 is A. Let's go to 16. The form factor is the ratio of. So here, form factor. When we talk about form factor, we are looking at what? Form factor here is going to be equals to the root mean square value, right? Let's say we are talking about voltage. Root mean square voltage over the average value, meaning the average voltage, right? So this one, like we said, so it's going to be equals to what? The root mean square value over the average value. That is form factor. So when you look here, we have A, peak value to average value, then C, peak value to root mean square value, B, average value to what? Root mean square value. Now we get here root mean square value to average value. So the answer here is D. Now question 17. Question 17. The period of what? Of a wave is. So here this is just to see whether you understand the definition of what a wave, or whether you can actually define what whether you can actually define a period rather, right? So if you have a period, a periodic time, whether you understand the definition. So we have here question 17. The period of what? Of a wave is A, the same as frequency, B, expressed in amperes, no, C, time required to complete, right, one cycle, then D, none of the above. You can see here is C, right? When we talk about the period or the periodic time, right, so is the time taken to complete one full cycle. So if you have one full cycle, so let's say for example I have a sine wave, I have here pi, 2 pi here. So a full cycle is going to be this way. So the time that is going to take me to complete this here, right? This is what we call what? The periodic time, or the period. So the answer here is going to be C. Now let's go to 18. Question 18. a sine wave has a frequency of 50 Hz. Its angular frequency is, so if I have a sine wave 50 Hz, its angular frequency, which is omega, so we are talking about omega. So omega, which is angular frequency, is going to be equals to 2 pi times what? Frequency. So if the frequency is given as 50, 2 pi times 50, so that will give me 100 pi, right? Remember, radians per second. Radians per second. So when we look at the possible answers here, we have A. So you can see here A is the right answer here. Okay, we have A. Question 19. What is the period of a 50 Hz voltage and a 1 megahertz current? All right. So let's say you are given, first you can see that the frequency here is given as what? 50 Hz, right? That is question 19. Okay, let me write here. I'm now trying to solve question 19. Frequency for the first voltage, right? For the voltage is given as 50 Hz, right? And you are to find what is the period. So the period for the voltage with 50 Hz is going to be equals to inverse of what? The frequency, right? So meaning here will be what? 1 over 50. So if you take in 1 over, that is just 50 inverse, right? That will give us 0.02 second, right? So if we were to convert this to, let's say, milli, right? So that is going to be equals to 1. So you move the decimal point, that is going to be 1, 2. Then we can add another one so that we get milli, right? So 3. So it's going to be the same as 20 milliseconds. 20 milliseconds for this. 20 milliseconds. Now that is for the voltage with this with 50 frequency, and then a 1 megahertz current. So that one too we have to calculate for the period, right? So this one for the voltage. Now the period time for the current. Again, is going to be equal to inverse of the frequency, and the frequency for the current is 1 megahertz. 1 mega, right, is the same as that mega, which is what? 10 raised to the power 6, right? Hertz. So that's what this means. So the periodic time here is going to be equals to 1 over 1 times 10 to the power 6 here. Now with this, that will give us, so when you now change 1 over 1 mega, right? That is, so this 10, 1 over, basically 10 raised to the power 6. So you bring this on top, you get 10 raised to the power minus 6, right? And 10 raised to, so seconds, and 10 raised to the power minus 6, that is going to be what? Micro. So meaning for the current, the periodic time for the current is going to 1 microsecond. So you can see that we've gotten what? We have gotten, this one here. We have gotten 20 milliseconds and then 1 microseconds. So we come and look at our answers here. You can see we have 20 microseconds and 1 micro, which is wrong. So you can see the answer here is what? B. We get answer B. So that was question 19. Yes. Now let's go to question 20. Question 20. Determine the period and frequency of the waveform shown in the figure below. So we are given this figure here. You are to find the what? The period and then frequency. So I think the first part, which is 20, question 21 here, you are to find the frequency, right? You have to find the frequency here. So for the first one, you can see that here, if you look well here, we are given in the period. You look at the graph very well. For period, you take it over what? A circle, right? Meaning the time required to complete 1 full circle. If you look at what? The first one, which is T1 here, right? You can see that here it started from 0. But this one, the time here that they are indicating here, it didn't reach what? This part, right? It didn't reach, it has to complete. But when you look at this one, though it started earlier a bit, you can see that one what? Complete, right? So here, this one, we have the period returning to be 10 milliseconds. So with this, you calculate the frequency from there. So frequency, which is going to be what? Inverse of the periodic time, which is 1 over 10 milliseconds, which is 10 to the power minus 3. So this will be over 10 raised to the power minus 2, right? So this one, you bring it up so that you get 10 raised to the power 2, which is what? 100 Hz. So we get here the answer here to be 100 Hz. So the answer here is what? D here. Now, what is the period of a 50 Hz voltage and 1 megahertz current? It's like I solved this earlier. Okay, this is a repeated question, right? Question 21 here is repeated. It's the same as question 19, right? So here is going to still be B here. Now question 22. Question 22. An alternating voltage is given by V equals to 282.8 sine 314t. Find the root mean square voltage. Again, to find the root mean square voltage here, you come and use the formula. Root mean square voltage will be equals to 0.70 times the maximum voltage. So when you look at this sine wave that is given, right, the maximum voltage here, Vm, is what? 282.8 volts. So that means that the root mean square value here is going to be equals to 0.707 times 282.8. So when you do this, you get 189.9, let's say 4. So when you round this off, you can see when you look at the possible answers that we have here, right? Okay. 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 Yes. So when you look at the possible answers that we have, you can see that we have 200, right? You can see 200 is what? When you round the 189.94, you get 200. So the answer here is A. Now question 23. Question 23. Question 23 here. What is the frequency of the alternating voltage given by V equals to 282.8 sine 314t? What is going to be the what? The frequency. What is the frequency? Again, we know that angular frequency, which is omega, is going to be equals to 2 pi f. And to get this, our omega, you can write the what? The general expression, which is always the instantaneous voltage will be equals to the maximum, let's say, voltage sine omega t plus or minus phase angle. But you can see that with this alternating voltage, the phase angle is not there, meaning 0. So I can write this way. So by doing comparison, so if we were to write the sine wave that we are being given, which is V equals to 282.8 sine omega t here. So if, okay, here, remember, let me put the actual values here, which is 314 t here, right? So if you do comparison, you realize that angular velocity here is equals to 314 radians. So to get the frequency, frequency, you make frequency the subject here. That will be omega over 2 pi, which is going to be 314 over 2 pi. So get frequency 314 divided by 2 pi. So you get 49.97 Hz. So we come here and look for that answer. You can see that we have 80, 25, 55. We have 50. So 49.97. When you run, you get 50. So we get D. Now, question 24. Calculate the instantaneous value of the voltage V, which is equals to 282.8 sine 314t when time is equals to 4 milliseconds. Here we are now to find the instantaneous voltage. What instantaneous voltage just means is that I can always find the voltage, right? Anytime I'm given the time, right? So once I know the time, I can calculate the corresponding voltage, which we refer to as the instantaneous voltage. So if we are given, if you look back at the alternating voltage again, you can see that it is expressed in terms of time here, right? Look at this one here. You can see we have time here, right? So you can see that we can vary this time. We can start from time equals to 0, time equals to 2 milliseconds or any value. So, but for this case, for question 24, we are asked to use the time here to be equals to let's say the time t is equals to 4 milliseconds. So what is going to be the corresponding voltage? So I'll just come here, V here will be equals to 282.8 sine 314. In that place, you put the time, which is 4 milliseconds. That will be 4 times 10 to the power minus 3 here. So you put this. Now we try and simplify. Now with this question, you can actually get it is very easy, or you can get it very easily by just putting your calculator in radians, right? So if you were to put your calculator in radians, you can actually get this very fast, right? So I'm going to put my calculator in radians, then I'll get it straightforward. But let's say your calculator is not in radians. What that means is that you have to multiply the 314 by 4 times 10 to the power minus 3. And then you change that into what? Degrees, right? If not, if your calculator is in degrees and you don't change it, then you get it wrong. So I'm going to put my calculator in radians. Right. So I have here 4. Have my calculator is now in radians. Once I've done that, I can now write 282.8 sine 314 times 4 times 10 to the power minus 3. Okay, and you bring another bracket. So now I just put my answer. You can see I've gotten the answer to be, my answer here is 268.90 volts. So when you check here, the answer here will be what? A. Right? So now once I'm done, I'm going to change my calculator back to degrees, right? So once you are done with this, you change your calculator back to degrees. Okay. Now let's move to question 24. 24. And that was question 24, meaning we are moving to question 25. A sine wave has a frequency of 50 Hz. What is the angular frequency? So this is the same question we solved earlier, right? So question 25 here we solve it is the same question. Even here there's even a mistake. I think here is supposed to be 25. So that we get what? 50, right? So let's say here we put it to be 25 Hz. So that if we were to calculate for the angular velocity, we get 2 pi f, which is going to 2 times what? 25 times pi, which will be 50 pi. So that we can use C as our answer, right? So we have here question 25, so that we can use C as our answer. So there is a mistake here. The frequency is supposed to be equal to 25 Hz. Okay, so the answer here is C. Now we look at question 26. The root mean square value can also be called the maximum value, average value, effective value, and then none of the above. So the answer here is C, which is effective value. Another name for the root mean square value is the effective value. Question 27. 27 here. A sine wave is the same as the square wave, no. Sinusoidal wave, rectangular wave, none of the above. So here the answer is going to be what? B. A sine wave is the same as what? A sinusoidal wave. Now question 28. during each cycle, a sine wave reaches a positive value. So if I have, for example, a sine wave of this for only one complete circle or cycle here. So this is just a rough sketch, right? So you can see that during each cycle that I have here, I always reach what? You always have a maximum, a positive peak value here, which is here. All right. A sine wave reaches a positive peak value. Then a number of times depending on the frequency. A number of times. Then let's look at B, twice. No, you can see for only one cycle. For each cycle that is reach only one. Then we look at here, C is once, and then D thrice. So the answer here is C, which is once. So for each cycle that you have, we only have one positive peak value. Now, that was question 29 actually. Okay. Here it's just 29 that I've just solved. Then I'll just go and solve. Meaning I've skipped question 28. So now let me write 28 down here. Question 28 is where? Is here. A cycle per second is equals to, you can see question 28 here. That is going to be hertz, right? Remember, frequency is the number of cycles per second. So meaning if I have a cycle, meaning one cycle per second is going to add 1 hertz. Then we have question 30. The instantaneous voltage is always a fraction of A, period, B, peak voltage, C, frequency, D, none of the above. Here, this question, you can easily get it if you can remember what the general expression, right? You know that, let's say we are dealing with instantaneous voltage going to be equal to maximum voltage sine omega t plus or minus the phase angle. You can see here, because here is in terms of angle here, the whole of this part is dealing with what? Angle, right? And we have sine here, right? So because of that, so if you take sine of what? A number, so we are taking in terms of an angle, right? So that is always going to be a fraction of what? The maximum voltage here. For example, if you have here, if you have sine 90, right? Sine 90, we know you are going to get 1, right? But if you have now, let's say sine 45, right? Which we already saw, sine 45 over 0.707. So when you multiply V, and you see that it's going to be a fraction. We know that 0.70 is the same as what? 1 over what? Root pi. So here will just be 5, maximum voltage over what? Root pi. So that is just a fraction of this, of the maximum voltage, right? Which is the same as the peak voltage. So the answer here is what? Question B. So that is the end of what? The questions for today. We'll continue tomorrow. Try and share this with any of your friends or anyone that has taken applied electricity this semester. Bye bye. See you tomorrow.